Good morning, sir.
Good morning. Hi, sir.
Hi, Edric. Hi, Agatha. Everyone, good morning. Good
Good
morning to
morning, sir.
all.
Good morning, sir.
Very good morning. Very good morning, Ira. How are you?
I'm fine, sir. How are you?
I'm good too. How are you, Edric?
Sir, good, sir. So good, sir.
So good. Okay, that's great. That's great. So, yeah, today we were what we were doing in science.
Okay, so we finished all the resistance part. Now today we need to do heating effect of electric current.
But before that, I will give you one question so that I can know that you are getting this or not. Okay. So we'll do solve one question. बंद कर दिया यार नहीं चला नहीं पहला वाला चालू है गैस बंद है गैस ऊपर करना बस तुम लगा काम हो गई भैया किसी टैंकी में देखो खाना जाएगी मैं 32 स्टूडेंट्स है मैंने गिनती कर दिया ये ऑलरेडी काउंट इतने मैंने टेस्ट कर दिया कि आएगी क्लास
Sir, we already did this in last class.
Yeah, this time you guys will do, not me.
Sir,
Yeah.
can you send the recordings of the chapter 6? Remember the periodic classification?
Okay.
Can you send the recordings? I sent the
Sure,
message.
sure.
Don't know, did you see it?
Okay. It may be missed by me. I will send today.
Okay, thank you.
Okay, this is the homework question. You guys do it. Write it down the homework as a homework. Okay, so you guys do it in your home.
We
I
already
mean,
did this question, sir, last chapter.
last class.
Last class. We already did this question.
Yeah, I know, Edric. But because this is the one of the important question, that's why I'm giving this same type of question again, so that you can solve this. So write it down this question. Don't do it now. We will move forward. Which chapter you are doing? What chapter?
Are you talking to me?
No. I have the habit of I forget easily. So yeah, I got the chapter. Okay, done. Shall I erase this?
Yes, sir.
Okay.
Sir, I have sent you something in the chat box. Can you see that?
Oh, whoa, 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 whoa. Okay. So, okay. Okay. What's your last date? 15 December, no?
Yeah, sir. 15th December is the last day.
Okay. So we'll do one thing, guys. Okay, tomorrow onwards we will do TMA. TMA questions answers. First, we will continue with TMA because basically the 31st January is the last date of submission on site, but Miracle Study Center asked for the TMA before 15 December. So because of that, we have to do TMA now only, means from tomorrow we will start the TMA. So I request Ira and Miracle both. Yes.
Wait, our exams are next October, right?
Yeah, your exams may be on the next October. It will be the same. Means there is basically TMA is same for the April batch and the October batch of the same year. So, for example, if we will do the TMA right now, the same TMA will come for the October also.
But we have to submit our TMA before 15th December?
No. You guys who enrolled it, you guys have to submit it on before 31st January because the NIS gave the date 31st January. But Miracle Study Center asked for the TMA submission before 15th December. I don't know why. But it's okay if they ask. So we will cooperate with them and we will do the TMA tomorrow. Means the next 2-3 class will be the TMA class.
Sir,
Means I will give you the answers and you guys have to write it down. Then I will instruct you how to write the TMA. You guys do it, make a PDF and send it to me so that I can recheck it and then you submit to your study center or to the NIS site. You can upload it. Yes, Edric.
sir, can we do the TMA thing on like can you keep like an extra class so that this class we can continue and can you keep
Edric, I don't have extra time, beta, because I am fully packed. My morning class, my evening class is fully packed. I can't arrange extra class for that. And because the TMA is necessary for Miracle before 15 December, we have to submit it. So it's gonna be very difficult for me to arrange an extra class. So because I have my offline classes also. So because of that, I'm fully packed. So I can't arrange extra class for that. We have to do in this class only.
so that means for how many classes you'll take TMA?
Huh?
For how many
It
classes?
will take 3 class, max to max 3 class only.
So that means only this week it will be TMA and after that we'll continue.
Yeah, sure.
So and sir, you also forgot to correct the 4 tests that we wrote, 3 maths and
I know.
sir
I know. I told you now.
the installment buying the second test. I mean chapter 9.3 and 9.4
Yeah.
you didn't correct and 2 trigonometry tests and 1 periodic classification. Those tests
Sure. I will check it as soon as possible. This Friday, I guess I will give you the test now. So in your time period, you will do the test and I will check the test
Sir,
of the previous one. Yes, Agatha.
should students who are going to write the exam on October also write this TMA?
Yeah. I mean, you have choice. You can submit now also. Like if you enroll it, you will have an option to submission of the TMA. Okay. For example, if you want to give TMA in October, like you are giving exam in October, so you will have a date before 31st July. And the thing is, same question will come. Okay. The question which will come in right now, TMA, the same question will be there. So you have option. You have option. Like you have to write the answers which I'm writing on the board from tomorrow. Okay, but you have option that okay, I can write the TMA main paper now, or you can write main paper after May. Okay, after May also you can write the main paper. Okay, and then you can send it. You can upload before 31st July, like that.
TMA is for all subjects that we are going to do, right?
For all subjects. For all subjects. For all subjects. So, Ira and Miracle, send me the TMA worksheet PDF of both science and maths. So that we can do this week as a TMA week.
Okay, sir.
Only this week or this week and next week? Only.
I believe this week. So if you will cooperate with me, so we can do as soon as possible, because I also want to not waste my classes for the TMA. Okay.
Okay, so try to finish TMA by this week.
Yes, I will try my best. Okay. Now we will learn about one topic called as heating effect of electric current. Heating effect of electric current. Miracle, please send me the worksheet, the TMA PDF that you
Yeah,
got
yeah.
from.
I will send it today itself, sir, after the class.
Yeah, yeah. Okay, heating effect of electric current. Now, everyone, please pay attention. So, for example, this is a conductor, and in the conductor, what is conductor? That allows electrons to pass through it. That it means that that allow electricity to pass through it. Did you understand? Yes
Yes.
or no? Now, this we learned about that. Okay. Now, for example, this conductor has a resistance. Okay, resistance. So, Betya, what is the role of resistance in the conductor? Betya, what is the role of What is the role of resistance in conductor? To resist the
Electricity, current.
to resist the flow of current. To resist the flow of current. Okay. Now this is the role of resistance. But now current which is flowing from the source, means from the battery or from the power station, will continue try to flow through this conductor, and the resistance will continue try to stop the flow of current. Okay, did you understand? Resistance will continuously try to stop the flow of current, but because source, the power station, electricity is continuously giving, that electricity will flow. So because of that, electrons are flowing, resistance is stopping. So because of this war, there will be heat. Heat will arise from it. Heat will arise from it. That is called as heating effect of electric current. That is called as heating effect of electric current. Heating effect of electric current of a conductor is basically when electricity pass through a conductor having a resistance R, and for the time T, the heat arises. And that heat is basically called as energy. Did you understand? So the heat energy is basically I sorry the voltage which V is providing the battery providing the voltage into current into resistance into time. Okay,
No, wait.
did you understand?
No, it's not VIRT. It's VIT. R is not there.
Yeah, V into T. Sorry, my bad.
V into
So-
I into T. V into I into T.
So like voltage, how much voltage is applied into the current for the time period T? When you will multiply it, the heat will generate. Did you understand? So if I will like V is equals to IR, and if I will substitute the value into this, so for heating and heat energy, I will get answer as IR into I into T. So heat energy will depend on I square into R into T. Means where I is basically the current, R is basically the resistance, and T is for the time period, like how much time period. If it takes 2 time, then the heat will arise more. Okay, if for example, if you are using a fan for 2 hours, there will be normal heat on the plate of the fan. But if you are using for 20 hours, then because time is more, the heat will arise more. Did you understand? Yes or no? That is why it is necessary to give rest to the fan if you are using for continuously 14 hours. Otherwise, the coil, because of that heat, the coil will burn and the fan will get RIP.
Lunch
Did you
with
understand?
lunch with Jesus.
Lunch with season. So this is how the heat is produced. Did you understand, guys? Yes or no? Now everyone please pay attention. Edric, don't write, please. Okay. Now heat is directly proportional to the square of current. Okay. Heat is directly proportional to the square of current. It means that, guys, please pay attention. Please pay attention. Now, for example, the current is flowing, which is 2 ampere. But now I increase the current. Okay, the same resistance is there, same conductor is there. I increase the current. Now, if I will increase the current, it means that the heat will increase. Yes, because resistance is there. Resistance is already there. The resistance is not allowed to pass the current, but the current is coming. Now, more current will come, then more will heat will arise. Did you understand? Yes or no? So, if you will, better don't write. If you will increase the current, then the heat will also increase.
So the heat will
Yes
increase.
or no?
The heat will increase exponentially because it is ice.
Exponentially. Perfect. Heat is directly proportional to resistance also. Okay. Heat is directly proportional to resistance also. So what does this mean? This means that if you, thank you, if you will, if you will increase the resistance, then what will happen? Then what will happen? The heat will also increase because they are directly proportional. If you will, like for example, the current is coming, the resistance which was allowing little current, no, if you will put more resistance into it, it won't allow anything and there will be war between them, civil war. Okay, so the resistance will increase, the heat will also increase. Did you understand, guys? Yes or no? Agatha, Jashron, Miracle, turn on your camera. Did you understand?
Yes,
Any
sir.
problem, ask me. Yes, Agatha.
No, I just went to say that, yeah, I understood.
Perfect. Perfect. And heat is directly proportional to time also. Heat is directly proportional to time. For example, if you're using the wire for a longer time continuously, now because of that, time is there. If time will increase, the heat will also increase. So sometimes the wire will get burned also. Okay. We used to say na that put the geyser turn off, but yeah, everyone turn off the geyser. Why? Because geyser extract lot of current. If lot of current is coming for over the period of time, like for 1 month or 2 months, then the wire from where the electricity is coming, that wire will get burned, and because of that the house will become a bonfire. So we need to turn off the geyser if we are not using. We need to turn off the AC if we are not using, because it will burn our money also and it will burn our house also. So we need to take care of that. Yeah, just write it down. Just write it down.
Sir. Okay, sir. Finally, I'm able to write it down.
Yes, Edric. Edric, you were saying something?
Heat energy is equal to voltage into charge.
Yeah, voltage into charge. Perfect. Yeah, very good.
So voltage is IR and charge is IT. So it will become
Yes,
IR into IT, which is I square RT.
perfect.
Perfecto. That's
Perfect. Okay. Done?
yes, sir.
No, sir, do it.
If you didn't understand, ask me, okay? Just run.
Sir,
Yes, yes, Agatha.
heat energy formula is I square times R times T, right?
Yes, yes.
It's not VIT, right?
Both. It's
The VIT is the main formula. And from that, when I substitute the value of V as I into R, then I got the final formula. So VIT is the mid step. From that, we got I square RT. It's like that.
Okay.
If you didn't understand, ask me, beta.
so heat energy is equals to work. Work done.
Work done. Yes. Perfecto.
And it has the same unit joules.
Yes, we will go through work and energy chapter also. After that. After that, we will do one bio chapter, I believe. We'll do one bio, then we will do the physics or chemistry.
Chemistry, do 7 and 8, you forgot.
Yeah, yeah. Not forgot. We will do.
Okay. So next chapter, try to do this one. Next chapter, a 7 or 7 chapter or an 8 chapter.
Yeah,
Mm.
we'll check it out if possible. First, I believe first we have to do bio, one bio chapter, and then we will go to the next chapter.
Which bio chapter are you thinking of?
I didn't think yet because let the chapter be complete because TMA week is there. So I'll tell you as soon as possible, ASAP.
And math?
Maths, okay. Maths also I will tell you ASAP.
Next week, can you start both science and maths?
Yes, yes.
Science and maths, because you'll finish this chapter.
Yeah.
Done, sir. This I
Done?
finished this. Yeah.
Perfect. Okay. Now I will raise this. Shall I raise this?
Yes, sir.
Okay, everyone. You can write that unit of heat is joule. Okay. So, for example, 2 meter, 7 meter. In the same way, 2 joule, 8 joule means 8 joule of energy. I mean, the heat energy.
Sir, isn't
Yeah.
works unit joule?
Same. See, work. See, for example, everyone, please pay attention. This is what we say. I mean, I use in to cover my ears. Okay, so we used to say headphone. So, for
Earmuff.
example,
Earmuff.
yeah, ear muff, puff, or whatever that. Okay, so for example, if I will lift this ear muff for and doing work of 4 joule, 4 joule work I'm doing to lift up this ear puff or muff. Okay, so now how much energy I'm wasting? How much energy I'm wasting? 4 joule. I am wasting my 4 joule energy to do the 4 joule of work. So it means that energy and work both are relatable, means they both are same, means similar type. Okay, the work which I am doing, the, how much work I am doing, it is equals to how much energy I used. So somebody says, like many people used to say me that, sir, you have to do a work hard. You are a very lethargic person. So I said yes, because I love my energy. I don't want to waste my energy. It's a joke. Sorry for that. Okay. So basically, how much energy you use is basically the work done. Did you understand? So work and energy both are relatable, means they both are similar type.
Work
Okay.
and energy are same.
Yeah. Shall I use this?
Yes, sir.
Okay, write it down. This thing. Calculate. Calculate the heat energy. Calculate the heat energy if 9 ampere current is passed through a conductor. If 9 ampere current is passed through a conductor having resistance 10 ohm, having resistance 10 ohm for 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 3 hours, for 3 hours. Calculate the heat energy if 9 ampere current is passed through 10 ohm conductor for 3 hours. For 3 hours.
Calculate the energy if 9 ampere current is passed through a conductor, 10 ohm resistance for 3
10 ohm
hours.
resistance for 3 hours. Now you have to find heat energy. Okay, so Agatha will help me to solve this. Agatha, first of all, we have to write it down what is given. So, what is given in this question?
The current is given and the
So,
resistance
I
is
is
given.
equals to 9 ampere and resistance is given how much? 10 ohm. Okay. Okay,
Time is
next.
also
Next.
given.
Time is also given how much?
3 hours, but should we convert it into seconds?
No, no, no. We have to be remain in hours only. Okay.
Okay.
Now we know this. Now what is the formula for the heat? I square
Or
RT. So I will put I square means 9 square into R, which is 10, into time, which is 3. So H is equals to 981 into 10 into 3. Okay. So H will become 2430 joule. This is the answer.
then, sir, why can't we time in seconds? Then don't we measure in joules, no?
No, no, no. The joules is basically meter per second. Work is equals to heat is equals to power into time.
Yeah,
Uh,
power into time, and time is measured in
but time is in hours because kWh kWh, kilowatt hours. Uh,
No, it is in seconds.
it
But
is heat energy. Let me check on that.
T. Q, no, the charge, no, it is Q is I into T. Q is I into T. And T is measured in seconds. Same thing here. And energy is equal to VQ. So Q is there and is Q is the charge, no? And charge there it is I into T. And that time is measured in seconds. So we need to convert into seconds and then only we can measure it in joules.
No, because the next topic which we are going to do, that next topic is basically depend on P, the hours time, not on the second time.
It's seconds, not hours. Seconds.
Let me check. Let me check.
Check if it is seconds or hours. Mostly it will be seconds only. Oh yeah.
Give me a second. Let me check. Hmm. Okay. And kWh. Okay. Okay. So yeah, here we have to like time is basically is given as 3 hours. We have to convert that time into seconds. Okay. So hours means 60 into 60. So I have to multiply it with 60 into 60 so that I can get the final answer. Okay. Did you understand, guys? Yes or no? Here the time we have to use in second. Remember this thing. Time should be in second. Because it's heat energy. The next question which we will do in electrical energy, we need in hours. We'll do it. We'll do it. Shall I raise this?
So we need to multiply it.
Yeah, we have
Sir,
to
is
multiply
3
it.
times 60, 180?
Yeah, 180 into 60. So it will become 6 8 8 and then 4 4 6
Sir,
1080. Yeah,
why do we multiply two 60s?
because we have to convert hour into second. So 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. So 60 into 60 will become 1 hour in a second, which is
Oh,
3600. Remember this thing. 1 hour is equals to 3600 seconds. Okay, shall I raise this?
And multiply it. Somebody needs to multiply it.
Do it.
And then
Do
and
it.
then say the answer to sir and then I can do it with 81 into 108 is what? 108 into 80 is 8640.
Okay, so you do in your home, you solve it. We have to move forward.
Wait.
Now put a heading of electrical energy. Electrical energy. Okay, electrical energy. Now, you know that our, like, the electricity which we are using in our house, we get bill from government, a huge amount of bill. Yes. Okay. So how government calculate our energy, like how much we are using, how government find it out? That is the way they, like, how they create the bill is only based on the electrical energy that we use. Okay, that electrical energy E is basically the same formula of I square RT. Basically, what happened, I will tell you. See, we know that power is equals to work upon time. Power is equals to work upon time. Yes or no? Okay. Now, we'll not do this then. We'll first do the power one. Power.
Do this and power. Do this and power.
I will remove this. First, we will understand the power meaning.
And then do this. Then.
Okay, first we'll do the power one. Okay, so power basically means V into I. V into I. Okay, power means voltage into current, means a object like a bulb. When it consume 6 ampere current at the voltage of 220 voltage, then it is called as power. Did you understand? Okay. Power is equals to voltage into current. For example, this bulb is there, and if this bulb is there and it consumes 6 ampere current in 220 volt voltage, then multiplication of this will become the power of this.
That is the total energy.
That is the power of the object, power of the like bulb. Okay. For
Power
example,
energy
in
are
our
different.
power and energy, both are different. Okay, I will tell you. See, power is basically a object capacity to use the current. For example, if you will check the bulb, it is written as 9 watt W, 9 W power, 10 W power. That power is the bulb characteristics. It means that bulb is taking only little current for 220 volt. In our house, how much voltage is there? 220 volt is the voltage that government is supplying. And in that 220 volts, if they draw only 1 ampere current, so what is the power of that? 220 watt. Did you understand? Yes or no? For example, Miracle, turn on the camera, please. For example, our government is providing 220 volts as a in our houses.
Power source.
Okay,
Power source.
power source. And if bulb if bulb एक मिनट रुको मैं आता हूँ. If bulb consume 1 ampere current, for that, okay, so what is the power of that? Power is equals to V into I. V कितना है? 220 volt into I कितना है? 1. So it will become 220 watt power. Okay, 220 watt power is consumed by the bulb. Did you understand? Yes or no? How much power he consumed? 220 watt. The bulb Okay. So power is equals to 220 watt. Okay, power is equals to 220 watt. So now, for example, the bulb which you are using, it is only 10 watt. Okay, so for example, the bulb which we are using, it's only 10 watt. So what does this mean? How much current he is taking? So we know that government is giving 220 volt. Okay, so power is equals to V into I. Now this is multiplication, so it become P upon V is equals to I. Now how much power is 10 watt upon 220 is equals to I. Now if I will divide it, if I will divide it, 10 10 divided by 220 watt is basically I is equals to 0.045 ampere. Okay, so it means that the current, the bulb that you are using as 10W, 10W means 10 watt, is basically taking only 0.045 ampere current. Did you understand? So low watt power bulb will consume less current, and if you are using less current, then you are giving less electricity bill. Did you understand? So that is why before, in our times, we used to have 200 watt bulb, 800 watt bulb for the light. But now as we switch to LED, that LED consumes less power, means less current. That is why the electricity bill which we are coming, it's also less.
Sir?
Did you understand? Okay, so power is the product of voltage into current. Did you understand about the power?
Yes, sir.
Okay.
Okay.
Yes or no?
Yeah.
Pritya, Ira. Okay. Miracle, did you understand, beta? Yeah, write it down quickly.
Done, sir. And
The answer I wrote with you itself, so
sir. Miraculin is one.
Sorry, what happened?
Sir,
Yeah.
okay. Forgot, sir, but wait. How in this formula P is equals to VI, the current is inversely proportional to voltage. But in V is equals to IR, the current is directly proportional to voltage. How?
No, basically the power concept and the resistance concept is basically totally different. Here, the power is like the current and voltage are not interrelated. Here, the power and the current and voltage are interrelated. See, in that Ohm's formula, V is directly proportional to I, because if you will change the V, the I will change. Yes or no?
Yes, sir.
That we learned in the Ohm's law.
The
Now,
V,
in this
the
case,
V, in there, if
in this,
the V increases, I will increase. But here,
yeah, here, the I will not increase because the power is basically the characteristics of a bulb. If bulb needs more power, more current will go. Okay, so here, if you will change voltage, if you will change voltage to 400, it doesn't mean that current will go up and down. The resistance of the power is basically take as that current only. Okay, so if you will increase the voltage, like for example, in our house, sometimes voltage up and down. So if voltage up, the bulb will go more lighter. If voltage down, the bulb will glow less lighter, because voltage is providing current also, and that much current only passing through it.
yes, sir.
So from this formula, we can't tell that power is inversely proportional to current. It's same as that only, but the power is the characteristics of a object that we are using in our house.
Yes, sir.
Okay, I will erase this. Okay. So as I told you, what is the formula for power? Power formula is voltage into current. Now, if two bulbs having power that and that. So for example, if if they want to find it out the current and all. So if objects are connected in series, if objects are connected in series and in parallel. Okay, everyone please pay attention.
Yes, sir.
Okay, everyone please pay attention. For example, two bulb when they are arranged in series and two bulb when they are arranged in parallel. So when they are arranged in series, in that case, what is same? I is same. I is same, like current is same. We know that when they are arranged in series, the current is same in both the bulb. In that case, we know that P is equals to V into I. Now, if I will, like V is equals to IR, if I will substitute a value into this, so it will become IR into R. P
I.
is equals to I, oh, sorry, into I. So I square R. So what does this mean? If they want to find it out the power, if two bulbs are connected in series, then we will use this formula I square R. I square R. Did you understand? Yes or no? And if the bulbs are connected in parallel, in that case, we know that P is equals to V into I. Now we know that V is equals to IR, and V upon R is equals to I. If I will substitute the value into this, so it will become P is equals to V into I. P is equals to V into V by R. P is equals to V square by R. Okay, so if they are connected in parallel and if they ask you for finding the power, then like this we will find the power. If they are connected in parallel, the formula will become V square by R. If they are connected in series, the formula will become I square R. Why? Because in series, I is constant. In parallel, V is constant. That's why we are using this formula. Did you understand, Ira? Agatha? Miracle? Justron? Ask me.
Sir,
Yeah.
in series, the current is constant, so we use current in there. But in parallel,
Oh,
voltage is constant, so we use voltage in there.
yes. Perfect.
Agatta.
Write it down quickly. Yes. Agatha, any problem? Ask me. No? Miracle? Justron?
No,
Ask me,
sir.
beta.
It's clear.
Okay. So the power SI unit is watt. Betya, what is the SI unit of power? Can you tell me? What is the SI unit of power?
What?
Yeah, that is I'm asking. What is the SI unit of power?
W.
What is W? What W stands for?
What, sir? You have written it, sir.
Miracle, you.
I am what I written. I written WATT. What is that?
That is called what?
WAT
What means?
what?
So that's why I'm asking. What is the unit of SI unit of power?
What?
Yeah, what is the? I'm
What?
asking the question. You're asking me.
What is the SI unit? What? WATT.
It's watt.
Okay, okay. It's
Stop it.
watts. Yeah.
Stop it.
Okay. Now everyone, please pay attention. See, 1 watt is equals to no. 1 kilowatt kW is equals to 1000 watt. Okay, like 1 kilogram is equals to 1000 gram. In the same way, 1 kilowatt is equals to 1000 watt. Write it down this also.
But sir, when I go on to like my like the
Oh.
home screen like of the NIOS website, it's not
Oh.
allowing me to go into the TMA section.
TMA section, no? So it means that you will submit your TMA in 31st July only. So Miraculin has the PDF because Miraculin will give exam in April. So Miraculin has the PDF. So we'll do one thing. Miraculin will send me the PDF. We will do that answer so that it will be same for both April and the October one. So you just write it down in your rough copy. When your time will come, you will write it down. Okay? Okay. Shall I raise this?
Uh,
Okay. Okay. So now we will understand the electrical energy. Electrical energy is the energy that how like electrical energy is the energy like if we use electrical energy based on that the government will charge us money for that. Did you understand? Yes or no? Now everyone please pay attention. For example, a bulb I'm using in my house only one bulb. Okay, that bulb has power. For example, the bulb has 220 watt power. It means that only that power over the period of time, if I will use, the government charge for that only. For example, just give me a second. Yeah. So for example, if 220 watt power I am using for 1 hour. So 220 watt power into 1 hour, that will be the electrical energy I am using, and according to that, government will charge me. For example, 220 watt power bulb I'm using for 100 hours. So I will get more bill, like 100 hours I am using, no? So it means that electrical energy basically means as power into time. How much power I am using into time. Into time. Okay. Now, electrical energy always measured in the form of kWh, which means that kilowatt into time. The power should be in kilowatt and the time should be in hour. H means
so this can also be measured in joules, no?
yeah, we can measure in joules, but for the government it will be very huge number. And because to make it simple, they made it in kWh, kilowatt per hour. For example, for example, okay, okay. First, let me complete. Then I will tell the answer of that. That 1 kWh is basically 1 unit. For example, in your meter, when you will check, number is written as 2489, and after some time it will become 2490. After some time it will become 2491, like that. No, you have meter. If you will check that one unit which is increasing in the meter, it means that you are using 1 kWh hour electrical energy. Okay, 1 kWh is equals to 1 unit in the meter. Okay, did you understand?
So 1 kWh is equal to how many joules?
How many joules? It's 3.6 into 10 to the power 6 joules per second. Okay, I will let you know how it came. Okay, first let me complete. Attic, don't interrupt me, beta. I will give you the time to ask. Okay, 1 kWh is basically 1 unit. So what does this mean? This means that if you are using 1,000 watt power in 1 hour, you are using 1 unit of the government. Okay, I just told you that 1 kW means 1,000 watt into 1 hour is basically 1 unit. So from that, like we have 1,000 watt geyser. So if you are using 1,000 watt geyser for 1 hour, it means that you are giving 10 rupees to the government, because government charge 1 unit as the 10 rupees. Some states have different values, but in our state it is 9.70. Means if I will use a geyser of power 1,000 watt for 1 hour, so for that 1 hour I will give government 10 rupees in one day. If it is for 30 days, then I have to multiply 10 into 30, means 300 rupees for the bill for my geyser only. We have like other appliances also. Did you understand? Yes or no?
Yes, sir.
No. Okay. So E electrical energy is equals to power, which can also be written as I square R into T time. So the formula will become I square R into T.
I square
I
R T.
R into T. Write it down, everyone. Write it down, then I will give you one question.
So are we finishing this chapter? Sir? Sir.
Done, sir.
Yes, Edric. You're saying something.
Sir, are we finishing this chapter today?
Yes, Edric.
Are we finishing this chapter today?
I believe so.
Done, sir.
Okay, done. Shall I use this? Now write this question. Just give me a second.
Where is Joshua?
Write it down. Write it down. Find the electricity bill. Find the electricity bill if six lamps six lamps of 40 watt each, if 40 watt each is working for 4 hours per day, for 4 hours per day. Second part, in that only second part, two tube lights, two tube lights, Betty, are you there? Okay, two tube lights, 125 watt each.
Wait,
Two
is
tube,
this a new question?
no, same question. 6 lamps, 40 watt each, working for 4 hours per day. Two tube lights, 125 watt each, working for 2 hours per day. Third, 1 kilowatt heater, 1 kilowatt heater, working for 3 hours per day. 3 hours per day.
What
Each,
family lives in that house, sir?
huh?
What family lives in that house? You need 3 hours for one turn.
Hello. If you will come to North, na, then you will become that family.
Yes, Ron.
Because you so much cold is there. Ask Miraculin. He's not
Miraculin
coming
is
up.
ultimate. Miraculin is ultimate.
Yeah. Miraculin, how's the cold there?
Like now it's normal, but it's cold.
Yeah, it's cold. Okay. So 1 kilowatt, 1 kW heater working for 3 hours per day. If the month of April is there, and each unit cost 10 rupees. If month of April is there and each unit cost 10 rupees, find the electricity bill, which is the first part. Okay. Find the electricity bill. Okay, this is the easiest question. Okay. So first of all, we have to calculate the power.
Find
Yeah.
the electrical.
Find the electricity bill. Find the electricity bill. Now, everyone, please pay attention. Don't write anything. I will give you time to write. Please pay attention. First, it's 6 lamp of 40 watt each working for 4 hours per day. Means 6 lamps. Okay. Total power consumption of lamps. Okay, so it's 6 lamps, 40 watt each. It will become 240 watt, and for 4 hours per day. So if you multiply it, it will become 0, 16, 960. So it means that 960 watt is using by the lamps in a day. Did you understand? Yes or no? Guys, did you understand what I did? Like 6 lamps, 40 hours, 6 lamps, 40 watt each, it's become 240 watt. And for finding the electrical energy, we know that power into time. Okay, so power is 240, time is 4 hours. If you multiply it, it will become 960 per day. Means 960 watt is using in per day by the lamps only. And because it's a month of April, so we have to multiply it by 30 also, so that we can get the answer. So if I will multiply it, it will become 82880, no 29. It's a 2880 watt. So it means that in the month of April, lamp are using 28,800 watt. Did you understand? Watt per watt hour. Now, if I will convert into kilowatt, so I have to divide it by 1,000. So it will become 28.8 kilowatt hour is the used by who? Lamps only. Did you understand, guys? Yes or no? Why I divided by 1,000? Because it was in watt, and for changing watt into kilowatt, I have to divide by 1,000. In the same way, now we have to calculate for the tube light. Tube light. The tube light is 2 tube lights, 125 each, which will come 250 watts into how much per day? 2 hours. So it will become 500 in a day, and in the month of April it will become 30. So it will become 1500 and 0 watt per hour. And if I will divide by 1,000, it will become 15 kWh is used by the tube light in the month of April. Did you understand? Agatha, Miracle, ask me if you have any doubts. Petya, Joshua, no, I mean Jashron. Okay. Now, if I will talk about heater. So heater is already in kWh. So I will not change the value into kWh, but heater is working for 3 hours. So it will become 3 kWh in day. I have to multiply it by 30 because it's the month of April. April days. When you say heater, I'm saying water heater, not water heater. Or not water heater. So it will become 90 kWh in the April month. Now, how much total electricity used? First is 28.8, then 15 kWh, then 90 kWh. Add it, 90 plus 15 plus 28.8. Okay, so it will become 105 plus 28.8. If you will add it, it will become 133.8. Okay, and government is charging 10 rupees per unit, because 10 rupees per unit, na? So it will become 1,338 rupees for these three things. The total bill is 1,338. How it become? Because total unit use is 133.8. Okay, and then I multiplied by 10 because government is charging 10 rupees, so it become 138 1,338 rupees is charged by the government. Did you understand, Agatha? No. Ira, Agatha, Miraculin, Justron, ask me any doubt.
I understood, sir. That's very easy question.
Wait,
Very
wait.
easy.
Total power consumption of lamps. So 6 into 40, which is equal to 240 watts into 4. So what is that?
6 into 40. Like 6 lamps of 40 watt each. So the total lamps is become 240 now. And for 4 hours in a day, so it become power into time. So that is become 960 watt in a day. So I multiplied by 30, so it become total in a month. And then I convert into kWh, so it become 28.8. Did you understand? Ira, Edric?
Wait. Sir,
Yes, Edric.
I think the KWH, no, it is KWH is written in small k, capital W, and small h. It's not all of them small. This capital W.
No, you can write like that also. There's no writing problem in that.
Small k, capital W, small h.
Okay, okay.
Sir, I'll type it in the chat box and show you. It is like this. Like this. Like this. Oh no.
Okay, done. Shall I raise this? Okay.
It's already 11:30, sir.
Yeah.
Wait.
But this question, it's very easy. Like,
Yeah. Okay, so we'll end this class. If you enjoyed the class, it's very good. If you didn't enjoy the class, it's also very good because I enjoyed the class. So I hope you all enjoyed the.
Miracle!
Till then, bye. Have a nice day. Signing off. Ita Shabak here. Tayo. Nara. Signing off.
bye.
Thank you, sir. Bye.
Sir, did you complete this chapter?
No. Still one topic is left.
So do it tomorrow and then start with TMAs.
We'll check it out. I request first Miracle to send the TMA just now after the class, then we'll solve it.
Sir?
Yes.
Then bye.
Sir. I have a doubt, sir. One thing regarding. Sir.
Yes.
So, I just went for like a PCP class and